Hello, this is Laura Wogzogen, your math instructor this semester. This is going to be a brief video that goes over Project 2, which is on Old Faithful. And so again, in modules, you'll have a folder that is going to be for Project 2. And for Project 2 Old Faithful, there's some history here. We are going to be using a data set this time in StatDisk. So this is going to be an individual project, just like before. It does need to be typed. Make sure that your answers are unique for you. And the project also does need to be typed and then correctly labeled, and the parts need to be completed in order. And then we are also going to be using StatDisk again. And the points for each part are listed, and the total points that can be earned are 45. Parts 1, 2, 3, 6, 7, 9, and 10 all have to have screenshots. So a lot more than project number 1. And so with this, it says screenshots should be legible and inserted into the project in the correct spots. You also must provide and clearly state specific answers. Answers need to be rounded to 3 decimal places, label axes on graphs, and no points are rewarded for using a graphing calculator for those screenshots or for the StatDisk part instead. Objective, again, is to gain knowledge of working with StatDisk. And so it says the distribution of Old Faithful eruptions data does not need to be attached. So the first thing is at the very bottom of this is it talks about how to actually access this data. And so I'm going to go ahead and access the data first by using StatDisk. And then I'm also going to look at numbers 1, 2, 3, and then we'll pull up StatDisk. So 1 is asking for the mean and the standard deviation of the duration in seconds of the 250 eruptions. So we've done this before. We did this in Project 1 with the mean and the standard deviation. 2 says to create a histogram, which we also did in Project 1, but this time it says to use the auto fit option for class width. So we'll look at that. Number 3 says to create a normal quantile plot of the 250 Old Faithful eruptions. So opening up StatDisk, if you remember, I don't have any data that's in here yet. Our data we need to get from, and again, it's at the very last part of that project, selecting 14th edition. And if you scroll down, you'll notice that you have a bunch of different data in here. And so we have one that's that does say Old Faithful, so I'm going to select that, and automatically it just pulls in all that data, which is great. And so in order to do this, I want to go back to our project really quick. It is asking for the duration. So make sure you look at that data to figure out which column has duration in it. And if you look at that, it looks like that's in the second column here. And it does say duration in seconds. So one of the parts was asking for our descriptive statistics, which was the first one. So you select that and then select which column it is we're looking at, which we did in Project 1. The next one's going to be asking about the histogram. I'm going to select this. It's a little different. If you notice, we do use this auto fit option that's down here. Selecting the column, it was on duration. And then you need to make sure that you change your title, your X and Y labels to make sure it fits appropriately with the data. Going back to a StatDisk, the other thing that we had was number 3, which was new, is going to be creating a normal quantile plot. So I'm going to select that. And if you notice on here, it says select the column of data that you want, which again is duration. Then you can give it a title and also the X value label on what you have, and then plots. And then again, taking your screenshots. So this was numbers 1, 2, and 3, briefly gone over. 1 and 2 we've done already in Project 1. 3 is new. Then number 4 says, does it appear that Old Faithful eruptions are from a population having a normal distribution? Clearly explain. So you need to check section 6.5 for help. There's going to be 3 things that you need to check. Make sure you check all 3 things. Number 5 says clearly check to make sure that the requirements for using a t-distribution are satisfied. in obtaining a 90% confidence interval estimate of the duration of Old Faithful eruptions. Show any required work and clearly explain. So looking back at your notes, you'll notice that there are requirements that have to be met in order to actually find our confidence interval. And so you want to go back into your confidence interval notes and look at the requirements that you need for the mean duration time on Old Faithful. Number 6 and number 7 are creating confidence intervals. And this one says for the duration of Old Faithful eruptions using the T distribution. So one says a 90% and the other one says 95. These ones do require us to use StatDisk. So going back to StatDisk, and we are looking for confidence intervals. You'll notice that's not in our data, but analyzing our data, you have confidence intervals here. You need to think about if you're dealing with one sample or two samples. So right now we're just dealing with duration, so it seems like it's just one. And then are we talking about the proportion or are we talking about mean? So you need to think about that and select the correct one that we have. And then when you do this, it's going to ask for to use data is the easiest one to use. Your confidence level you type in there. Select the column that you would like to use, which again is still duration, and evaluate. It does say if you know the population standard deviation. If no, but we do not, so don't put anything in there. And you're going to have to do it again for 90th percent confidence interval and a 95% confidence interval. Number 8 says what happens to your confidence interval as your confidence increases. So make sure you explain that using the same wording that we use in our class, and then also make sure in sentences. Number 9 says using the data sets, find the probability that the duration of an eruption of Old Faithful will be 240 seconds or longer. So we are trying to find a probability here. And so I'm going to go back to StatDisk and look at this. I'm going to go back over here, and we're looking for a probability. So if you notice on analysis, there is a probability distribution. We are going to use the normal distribution since our sample size is large enough and we have a simple random sample. And if I select normal, it's going to ask for a Z value here, or the area. We don't have that area, but we can calculate the Z value. So going back to our project, the value that we have here, the X is, that we have is for number 9 is 240. We have the mean and the standard deviation back up in number 1. This is just like what we did in project number 1 too, to calculate that Z-score. And so we go ahead and calculate that and put that in for our Z value, rounding 3 decimal places, and then hit calculate, and it will tabulate a whole bunch of information for it. It does want 240 seconds or longer, so think about where your answer would be in the output that's given. It's going to give you going area, going to the left, going to the right, going between. And then we have number 10. It says, is your result from part 9 significantly high, significantly low, or not significant? Clearly explain your reasoning. So very similar to project 1. And then number 11, we need to also have a screenshot for. This one is very similar, except for with number 9, it was just talking about an eruption, whereas number 11 is talking about 25 eruptions. So remember that this is going to change your standard deviation, so definitely something to go back and look at your notes. A good example to look at for your notes is we had one that was on cobalt, and we also had one that was on Coke, the drink. And so going ahead, it's going to be exactly the same thing, but you're going to have to calculate that Z-score. But again, that standard deviation is going to change because it's dealing with 25 eruptions and not just one. So this is our brief introduction to Project 2. Again, places to work and get extra help would be at the Marks. You can also stop by during office hours and then also get to know your classmates and work with them. But again, make sure you do your own work. If you have any questions, let me know and get an early start on this. Good luck.